I would like to talk about the challenges of protecting and securing popular AI and machine learning models in a hardware-assisted trusted execution environment, while referring several instances of attacks on popular framework of machine learning models. We can also deep dive into the threats and risk of machine learning in modern mobile devices, from API extraction threats to intellectual property protection. I will detail some attacks about the graph neural network and large language model as well.
Welcome to TALK.CYBERCNI.fr.
Bienvenue.
Welcome to Talk CyberCNI. Today we do not only have the first edition of 2025, but it's actually also the 42nd edition. And those knowing Hitchhiker's Guide Through the Galaxy, for instance, they know the importance of this edition. And therefore I'm super happy to welcome Soumya Banerjee today again for a super interesting talk. So the last time we heard about him was 3 years ago, and the series was about lattice-based crypto, if I remember correctly. And today we have something super interesting about the sixth sense for AI algorithms, challenges on confidentiality, trust, and security for mobile devices. And before we come to Soumya, before I introduce him, those following this series for a longer time know it already. I'll tell you a bit of the modalities, how you can interact, and so on. The series, you all know it, is about getting to know the different facets of cybersecurity. Last time we talked about fake news. Next time we'll talk about patents. And so AI, obviously super important. Recently, just last week, the Chinese DeepSeek model was published, which is quite impressive from the performance. The stock market was crashing about it. So this is the big thing in our time right now. And so therefore a super timely talk, and really thanks to Soumya that we have such a nice topic today. So how can you interact? As always, we have the second screen. The second screen is Slido. So this is a tool where you can scan the QR code that you see here, or you go to the website slido.com or sle.do/talk42, or you enter the code talk42. You know it as always. And once you go there, you can put your questions, you can follow, you can upvote and downvote questions. And so it's a very good idea. We'll use these questions for the discussion in the second part of today's edition. And as always, this will also be super interesting. Okay, so this from the technical perspective. So now let's introduce Soumya. So Soumya Banerjee is a Senior Vice President for Innovation at Trasna Solutions Limited. And he is also a senior researcher at the University College Cork in Ireland. And he has been specialized with computational intelligence, machine learning, security, and blockchain across smart and connected environments for almost 2 decades, and visiting both research and teaching. Prior to Trasna and UCC, he was invited research professor at CNRS INSA de Lyon in France, at TU Ostrava in Czech Republic, at the CNAM CEDRIC team in Paris, and still he's an adjunct senior researcher at INRIA EVA Paris. He has more than 150 peer-reviewed publications, IEEE, LSVA, Springer, and so on. And he has a European patent on bio-inspired algorithms from 2009 to 2011. And with all this huge background, I'm looking forward to hearing about the topic. And with that intro, I directly hand over to you, Soumya. We're looking forward to your talk.
Thanks, Mark, for the nice introduction, and thanks for the invitation. You have invited me for a super interesting talk, as you mentioned. I think you can see my screen. Everyone can see my screen. Yeah, is okay. Yeah. So let's start together. The most interesting topic and the buzzword of today, that sixth sense for the AI algorithms, challenges confidentiality, trust, and security for mobile devices. So I am representing Trasna Solutions Limited, as Mark mentioned. So before going and jumping into the topic in details, I will just present a kind of overview and agenda what I will be covering so far in the topic. First of all, we will introduce the genesis of problem statements, because whatever we mentioned the name and in the block of the slides, that was the initial curtain raiser, you can say. So normally we have to extend the problem statement in details. Then we will try to cover some of the background of the initial inputs, because we will be mentioning the hardware also, because part of this coverage will also touch the hardware part, that is the trusted execution environment. So we are doing, it's a kind of isolated execution environment. It can be protected or sealed, or you can say it is completely secured, and for secured remote attestations. So at the end of the day, what is desirable for a trusted execution environment, why it was so popular at that time, before 4 years or 5 years down the line, to protect our assets of the system if the software part is compromised. So I think this is the main buzzword which actually attracted the people all over the globe about the trusted execution environment. And if you can see the research and the background of it, you can say that there are plenty of availability of resources, like from 2019 keynote I mentioned here of CCS. Then you can go through the 2022 book. There is a famous book of the publication platform, the Security for Mobile Devices. So you can see that these all are integrated into a kind of trusted execution environment and trusted computing block. And most importantly, there was one paper which was becoming phenomenal at that time. I think it is 2022, and you can find it on the Xtreme. That is called the hardware assisted memory protection feature. That means you can protect your memory stealing, and it can be used as hardware and software tool as well. So broadly, this sense of trusted execution environment, you can see it that it has begin more than 5 years or 6 years or 7 years down the line, before AI sparkled into reality. So if you are going back in the details, little bit details, foundation details, then there is trusted computing base. There is a TCB, or trusted computing base, and you can see my screen that there are different parts. So fundamentally, the part of the firmware which is called SMM, that is called system management mode, and which is also defined as a runtime BIOS, and it actually gives the security protection for a software running in confidential computing environment. So that means this SSM firmware, if you can see that this SSM firmware is actually giving some kind of a good buzzword, then at the same time, what is happening is that with SSM, you have the hypervisor, you have the gateway, you have the app. So everything is configuring the entire trusted computing based, which is a basic and nucleus component for your trusted execution environment. So as I mentioned you, the trusted execution environment is a hardware environment, and it is backed up by enough software and protection unit. So let's see what are the different criteria of doing these things. So one thing was, at the same time, there was a potential solution that for this kind of system, that I told you that it can also offer the remote attestation. So the people are trying to use homomorphic encryption. Homomorphic encryption is a kind of encryption technique. It's not related to the AI, but it's a kind of encryption technique, specially used for the quantum machine learning or quantum environment. They use to have some kind of private key and public key combination, in terms of mixing it in an environment where you can make it remotely attested, or you can make it make the identity verified remotely. So what happens is that this kind of solution for the hardware block for the mobile devices, giving us lower convergence of the software. So solution was something like this, that we have to build a TE, that is trusted execution environment, with a very small TCB, so that the entire trusted execution environment you can carry with your mobile devices, with your laptop, with your tab, with your iPad, everything. The idea is that it should be small, it should be device specific, and it should not create entire great latency on the system itself. So what happens is that in the market there is some protection granularity comes, and trusted execution environment and trusted computing block are having different size as well. So you can see some traditional system, there is called ARM trust zone, and most popularly the Intel SGX, which is called software guard extensions, and trust domain extension, TDX and SDX. These are the couple of you can say couple of instances or industrial use cases which have been put forward to produce the small size of trusted execution environment which can fit with your device to protect your device software not to be compromised, right? So by this kind of input we can identify that trusted execution environment was a foundation model, and after that the AI and machine learning algorithm has been sprinkled into reality. So there is a huge kind of proliferations in machine learning architecture, machine learning model, algorithm convergence, etc. So obviously the trusted execution environment and trusted computing block was not so fast to catch up the speed how the AI and the machine learning have been really great, made the revolution. So what happens? There are some serious facts which have been happened so far. You can also find it from Google. You can see first is the North Korea, which has used Western language LLMs to generate fake resumes and profiles to apply for thousands of remote work jobs in Western tech companies. And surprisingly, these LLMs have been hacked completely. And once hired, these workers, usually laptop firms in China or Russia that are supervised by a handful or individuals, stolen or can be compromised. First of all, that we must see these kind of diagrams, that we have registered owners, we have a data set. Of course we need a data set to train our model. We have a trainer and we have a machine learning model. We have some API instances and we have a client. Now question is that where is the adversary or target identified? If the target is identified, what is the adversary? You can see my graphic scheme that it shows that this is the target adversary and it creates an attack. So what happens here, I'm going back again, it make a kind of evasion attack. This attack is called evasion attack. Evasion attack is an attempt to make a model output incorrect results by slightly perturbing the input data. You can see we have not given a kind of model stolen here. We have not attempted any kind of great threat here, but we have just made a kind of modification in the training data, and quite obviously your result have been impressed. So these kind of systems are quite dangerous and quite crucial, and slowly but steadily it can taken care the control of your system. So if you want to get a details, then you can see the two papers which have been followed here. Although these papers are quite old, but which is quite phenomenal. The first one is the Intriguing the Properties of Neural Networks, ICLR 14, where it has been published. Another is the KDD 2204, that is the adversarial classification of the different kind of attacks. So these are very primitive things that if you can just modify your training data little bit, slightly and partially, your entire output can be impressed or can be compromised. So what happened that there can be a malicious client which can just disturb your model confidentiality. So what is model confidentiality? You see that in this scheme, what happens, there is an email model and there is an inference service provider API and there is a client. So what happens that the gray color is the stolen model. The model has been already stolen. So what happens here that you cannot do anything because the entire model is stolen. The first step was to bifurcate your input data so that you can be deviated from the exact output. Now your exact model has been stolen. So what happens here that these are the two instances I am showing you, and these instances are showing that there are enough possibilities that whatever the machine learning model and framework you have started with your systems can be compromised at any point of time by perturbing your input data in terms of training, or maybe the entire model could be stolen step by step. So what are the different kind of verticals or different kind of direction where these kind of attacks can be uh, prohibited. One is that poisoning. Poisoning is the thing which I just mentioned you, and is the model stealing which just we mentioned. Then model inversion. This is another crucial approach, that whatever the model you have been targeted or you have been fixed, that has been inverted. Then backdoor ML, that you have done some kind of front end machine learning pipelines, and that has been completely backdoor by a backdoor ML which has been given maliciously to your systems. Then adversarial examples, there are different kind of adversarial examples. Then malicious ML provides us recovering training data. That is another big use case for this trustworthy AI. And of course, the entire supply chain of the machine learning can be attacked. So if you are approaching to build up or to consolidate a trustworthy AI model, these are the few points. I can mention many others. People can also put down other points as well, but these are the main verticals where we have to emphasize. So in terms of finding this thing, we have two efforts here. One is called that what is the defense against the model stealing, because people are not sure that model has been stolen. So first of all, that model has been stolen, it can be detected or it can be extracted reverse wise. So if the model has been stolen, it can be extracted, don't worry about that, or it can be detected that model has been stolen. And these kind of work have been supported by a good example of simulations. You can also have a look on these papers, increasing the cost of model extraction with calibrated proof of work. So this is a good and nice work which has been published by ICLR, and they showed that how the what is the cost of model extraction. Of course, there is a cost if your model has been stolen, and if you have to extract back to your system, that could be a cost. But to my practical experience, if the model has been stolen and model you have to extract back, then you cannot make it 100% I mean reverse. So you have to compromise certain amount of losses in terms of extracting the model. So of course there is a question that what is the desirable business model. In the desirable business model, we have a kind of model ownership resolution. So any machine learning model, whenever we want to bid with the machine learning model and develop the machine learning model on the devices or even in the cloud, we have two things in common. What is called watermarking and another is called fingerprinting. So these are the techniques which will give you a consolidated security. If there is a system which are attack prone, or there might be possibilities for different kind of attacks from different malicious users. So watermarking facts and possibilities, there are some kind of possibilities. One is the possibility that training the victim model, embed watermark while training the potential victim model, choose incorrect labels for a set of samples, and cannot resist model extraction. So you have to make a kind of watermark while training the victim model. And another is called embed watermark in the inference API. So you have to create a kind of API, inference API, and this inference API is not an open API. We have to make a watermark on the API, so that if or there is some instances the model has been stolen or had been compromised, the watermark can save you out for the extraction. So you can say it is a kind of reverse engineering to protect the attack, or rather to reverse or to extract your compromised software or your compromised portion of the machine learning model from the attackers. But at the same time, there are certain amount of other techniques. Fingerprinting is one of those other techniques which can make a kind of good distinguishment between configurable adversarial example and other transferable ones. And there is called data set inferences, and there is called grove. So these three things I should make and emphasize. Grove is a graph neural network embeddings. So in graph neural network, embedding is a property which could be given as a owner verification. So that means if you are the owner of the graph neural network, and if you are using a grove or embedding techniques, So embedding techniques give you a prompt of security that this graph neural network has been owned by you. That means there is an identity verification itself if you are using embedding in graph neural network. So graph neural network can be secured if there is a possibility of stolen the graph neural network, if there is a possibility of malicious attempts on the graph neural network, you can always integrate embedding on this, which can protect your models. Then there is data set inference, because there is a susceptible false positive and negative under conditions. This is also DI, it is called DI, and this DI or data set inference also making a huge impact on the machine learning models, especially the models which are very popular in the cloud side, like support vector machines or logistic regressions. So they have susceptible to false positive and negatives under certain conditions. So we need to create some conditions for these inferences, and this DI, the data set inference, can give you a protection if there is a possibility of some malicious attempts or attacks. So there are two model ownership resolution schemes apart from this watermarking and fingerprinting, because this is a very normal conventional method. As I told you, that these are extraction mechanism. This is not completely protection mechanism. So that means they have been compromised and they have been attacked. So these are the couple of instances still are going on, and we are not able to control those instances. But hopefully, I'm quite hopeful that within couple of years we will be having a full control of it, out of it. I mean, there will be less number of attacks, and if there will be less number of attacks, it is sure that these kind of compromises of injections, prompt, or you can say untrusted scenario verification mechanism, all should be more pure, all should be more trusted and worthy to discuss. Thank you so much for your attention. If you have any question, then you can have a shout or
Mhm. Okay, perfect. So super interesting, and it was a really large spectrum of topics about the super important topic of AI security. So thanks a lot. Let me just hide this one in our joint view. Okay, perfect. So yeah, really nice, because it's such a super important topic, and you really managed to cover so many aspects that was very good. It was really going around.
yeah, my objective was that we should start from the basics, that and I was showing some kind of instances where I was trying to make some hands on, that before going for the real Llama CPP or secured plugins. That is very important, that people are not knowing that what will be the secured plugins, and there are many frameworks available right now in the market commercially, like as I mentioned, Hugging Face, Mistral AI, but all are having different kind of loopholes. So we have to create our own algorithm, own strategy to make a trial and error. There is no deterministic method to apply this.
Hmm. Yeah, good, very good. So it's there are so many points to start. Maybe let's revisit some of the concepts you looked at first, to really make sure
Yeah,
the people got
yeah, sure.
the point. So about the watermarking. So what would you watermark exactly when you use AI? Where would you put the watermarks, and what would they look like, and who could do such watermarking? So which entity
Uh,
would be doing this? Is it a state
uh,
entity? Is it a service provider? Is it the
yeah,
user? Where's attestation done, and so on?
yeah. Watermarking is of course an attestations, and if you are talking about the who will do it, the watermarking can be done by the service provider. It is a dual end scenario. It can be done by the service provider itself, or it can be done by the developers, because whenever you are using developing a stack, then you can make a kind of two models. One is the watermarking, and it's called fingerprinting. So if you are putting an watermark, or you can embed the watermark, then probably your ownership verification has been justified. Say for example, graph neural network. There is a paper I showed, Grove. It is a very famous graph neural network paper which has been published in 2023, which shows that embedding is a property. If you can use embedding in the graph neural network, so each and every graph neural network has a unique embedding. So that means nobody can duplicate, nobody can replicate your embedding in terms of malicious attempt. So that can be one thing. So it means that it is a dual. You can produce in the algorithm as a watermark, as a function, or as a service provider. If you are a service provider, you can put a watermark to register and to verify your own model.
Mhm.
Now there is a question, what is the cost? Because many people ask me about the cost, because if you are talking about the watermark in the service provider domain, say for example you are talking about the eSIM or connected SIM or eSIM for IoT network, and I am the service provider of the eSIM, should I give the watermark to the eSIM? That will be a costly effect. So of course it will be a costly effect, but if it is a kind of watermark from your service provider, your service have been value added. So nobody is saying that your eSIM is without protection. You already have been watermarked. So eSIM marked by mark has been marked by yourself. There is no one which can duplicate your eSIM. So I am taking money out of you from you, but at the same time I am giving a value addition to you. So it is a dual purpose. You can put the watermark as a developer, you can put the watermark from the service provider. And most importantly, watermarking and fingerprinting, pruning, fine tuning, these all methods can be done with a good strategy of reinforcement learning, because this comes under policy. That if you are very much strategic and deterministic, that this is my policy, this is my headwards goal to protect my machine learning model in the device for the end users, then I can create a policy by my own with a reinforcement learning strategy. I can put watermark as a function, I can put a fingerprinting as a function, and try to create the owner verification at the end. So
Mhm.
it can be covered in the reinforcement learning itself.
Mhm.
So it is a business model, of course.
Mhm. And okay, very good, and also very good that you covered again quite a scope of topics. And regarding the attack scenarios, you were showing different attack scenarios like prompt injection and so on.
Yes, yes.
But the watermarking itself is rather for the model. And if the model would be changed, could you describe what the attack scenarios from the literature are? So, what exactly do they expect will be the effects of modifying the model?
If the there is I showed you that there is a point called model inversion.
Mhm.
Suppose you have created one model and in effect some other model have been shown in reality, but frankly speaking there is no kind of mechanism to protect model inversion if the model has been modified or changed at any point of time.
Mhm.
So question is that if somewhere down the line the model is stolen or model is changed, what are the impacts? So you, in this case we are not going to the cause. We have to show the impact. We have to detail in the impact. Impact is that, for example, I am using a logistic regression model or support vector machine in a mobile device. Can I do that? Question is that if I can do, probably my algorithm will fail, because support vector machine has a lot of computations which my device cannot support or may not support. So obviously the impact is that in the output is deviated, or output not at all giving any kind of classification mechanism which you are expecting.
Mhm.
So if you are asking me that is there is a strategy to give a counter method for model inversion, there is no strategy.
Mhm.
Model poisoning, prompt injection, there are many strategies which you can. There is llama guard, there is guardrails, you can have a lot of protection in the script. But if the model itself has been modified, you cannot do anything at the input end or at the developer end. You have to show the output end. That means the post training scenario is very important. As I told you, that is the multiple combination, def con defense, that there will be multiple combination of defense. So
Mhm.
this is one of the defense that you should be not be very much happy after the end of output. You should still make a good watch on your output itself. So the post training scenario is also very important.
Mhm.
Post training scenario can give you the idea that what kind of model has been modified, what kind of model has been inverted, and what are the effects of your output which was not desirable.
Mhm. Okay, and so to put it in other words, if, for instance, you use a large language model to learn the control of your factory, then obviously if the model is changed, then and there might be an unexpected outcome. If you
Yes.
think about text generation, it might be less obvious because it might even create garbage or something like that. But you might want to introduce some wrong facts or stuff like that. Even though I think this is way more far-fetched for this changing the model, because it's not at all obvious how you could get in fake facts easily to a model. Okay, cool. Then another question is that's a bit independent from your talk, but also super related. So all your mechanisms we were talking about were rather about traditional AI training and usage, which means the thing is running in the cloud, and then afterwards you're
No.
like
No.
protecting it. And you were also talking about the small language models which you can
Yeah.
train
Yeah.
locally.
Yeah.
If I understood correctly, with the DeepSeek, the model is, and also the reasoning thing is small enough that you can run it even on less powerful computers. Would you, from your experience with the technology, would you say there is currently a trend starting towards local execution and local storing of the model, or is it
Exactly,
rather?
exactly. That's why DeepSeek has been given as so much buzz noise globally, because they are executing the model locally. But there is a big question here that they are not very much transparent with the training data, where they have run the training data, whether it is a private server or whether it is a kind of data protection protected server. This is not clearly written, but
Mhm,
anything and anything comes in the future. Probably OpenAI should also think about it, that there might be some model who should come to execute locally, because
mhm,
people are very much curious at what is happening locally. They are
mhm,
not very much curious what is happening in the cloud. Even if it happens in the cloud, it is out of your hand, out of your control. But
mhm,
if you are executing locally, cost and the other parameters are really mitigated and really under your control. One
mhm,
thing is this. Another thing is that this is very much important, that neither OpenAI nor DeepSeek are given a prompt thing for the security purpose. They didn't mention anything about security.
mhm,
You see, in OpenAI, also in the chat GPT, there is no kind of source mentioned, that from where that source has been accused for. What
mhm,
is the source of training? They didn't mention. So
mhm,
this is a kind of tremendous alarm for the security part. And if you are talking about SLM, small language model on the mobile devices, still you will be a owner of the devices, if you will owner of the training data. So you are not concerning about the Google Cloud. So
mhm,
whenever you are going to the cloud, you have been sold. Your identity has been completely sold.
mhm,
So these are the advantage, but DeepSeek model has not been proved so far in terms of security. Even OpenAI, same thing. So
mhm,
they are not very secure. It is
mhm,
it is 100% sure they are not very secure. But
mhm,
it is quite sure that local execution model are becoming very popular. People are going for it, and the attacks, the possibility of attacks in local models, local execution models are less.
mhm. And this is also why I loved your talk so much, because as it's a still quite new technology overall, security was not the first-hand interest, because it was rather creating a proof of concept. And I really love that you showed so many aspects of the security, because in the end, the pipeline is rather complex, and also the attack vectors are rather complex. But at the same time, there are things
but
that
but
can
but
be done.
but but big question, Mark, big question, very common question. Whenever you are going to the market to acquire something, to purchase something, do you not ask the shopkeeper or the owner that it is secured, it is good, it is protected, not giving any kind of harm to my family? It is a normal and general question. So whenever we are trying to develop a proof of concept, it is a generic thing, and it is a by default sort of stuff that we should think about security at the same time,
Mhm,
not in the holistic way, but at least in some way or others, that we should think about security, that whether it is primarily secured or not, especially for the training part. If we are making a training data which is fake, obviously my output should be biased.
mhm. And so, I mean, of course, I fully agree with you. Especially as with the AI and large language models, it's already quite mysterious in some sense how what the outcome is, not because the steps are not explainable, but rather because there are so many complex relationships taken into account that the risk of an attack going undetected is significantly increased, I would say, because it's very difficult
True.
to to see that it was attacked, because between the input, because the only part of the input is known, because the model is not known in the sense that you know all input and so on, and so you only know what you put in, then a massive amount of things comes in through the trained model, and then you get an outcome. And if through all the steps you said, there can be manipulations, and
Yes.
for the human user or also for the automation, it's not at all obvious to detect something afterwards, and therefore it's super important to indeed project the steps so that it does not happen in the first hand. So I fully agree with you. And so,
Because I am telling you also the instances which is very relevant here. The I mean, before 20 years down the line, there was no LLM. There was called natural language processing, NLP, and NLP is the genesis of this large language model. And whenever we use NLP, we never thought of NLP will be used as a commercial purpose. We thought NLP can be used for the generation of book, generation of guideline, generation of storybook, generation of playbook for the kids. But we never thought that NLP can be used for a chat GPT. So the genesis, the theory of LLM has come from the computational intelligence, which is called natural language processing. But natural language processing gives the natural language, I mean, noun, pronoun, verbs, articles, identifiers, etc., prepositions. But they didn't say that it could be commercially used. Now it has been commercially used, so it is the high time to give a thought for the security.
I fully second that. So as the time already advanced, so what, maybe a last question. So how mature would you say are we at the moment with the use of AI? Would you say it already started to maturize a bit because now security is added, or would you still say probably
Yeah,
we are still somehow in the
security has been added so far, because I have seen the people, the good companies, I mean, from Samsung, from all other the tech companies, they are providing a lot more emphasis on the security. Especially there is one company called H Cortex. I should mention their name. It's from Japan. So they are also doing a good secured accelerator. And now, but only the question is that this security and this AI accelerator on the device side, on the mobile device side, are not fully proven. Fully proven means they are not given in a great adversarial environment. They are not given in an attack prone environment. And you know, the instances of the testing of those security are very limited. So you can have only 100 instances. So 100 instances cannot give you the foolproof guarantee that it has been fully secured. So I am telling that it is taking some streams on the tiny machine learning on the devices or edge AI, but I cannot say it is fully secured. And even a couple of years before, there is a private blockchain development. When I did something on the private blockchain stuff, I did make some kind of PUF, secured PUF, physically unclonable function, which has been protected by blockchain, but it has not been fully proven, because it can only prove 2 or 3 instances or 2 or 3 use cases, but it cannot be a generic theoretical saying that it has been fully proved. But it is hopeful that now people are talking about secured AI. Now people are aware that my identity uh, cannot be verified at any point of time. We can be sold, we can be caught, my bank can be empty at any point of scam with any scam. So all can be generated by AI. So people are aware of that. This is good thing. This is a hopeful thing. And if people are aware, then of course the technology should be there. If people are not aware, people are not conscious, then technology cannot give you any kind of hope.
And I think
Technology can be a bliss, but it cannot be a boost if we are not concerned.
And I would say this is exactly one of the big values of your talk today, because you made the people a bit more sensible of what could be potential challenges and what could be
Yes.
potential solutions for it.
Yes.
Very good. Cool. So big
Thank you
thank
so much.
you. It was really a great pleasure having you, and it was a really nice talk. So really thanks.
Thank you so much, and I'll be looking forward to working with you very soon again.
Perfect. And so for the series, so the next edition will be on the 7th of March. So we put it 1 week later, and it will be on hacking innovation, and it will be about why security needs patents and vice versa. So the working title, but it will be something with patents. And we have a patent attorney, Christian Moore, with us, who will be talking with us about that. Also a super important topic, because patents are very important for cybersecurity.
Very important, very important. Intellectual property protection is very important.
Yeah, and at the same time, it's also one of the topics that are not so much looked at. So yeah, very nice. Okay, cool. So yeah,
thank
then
you so much.
Join everybody on the 7th. And yeah, for those online, I show the outro, and see you. Stay safe, and until
Thank you.
Cher CyberCNI, pôle d'excellence région Bretagne. Au revoir et à la prochaine.